Alright, so we're doing 5.8 curve fitting with quadratic models. You're going to see how there's not too much to this one. We're going to try to do, all we're doing here is basically two things. We're going to decide if we look at the data, whether or not it's a quadratic function, and then we're going to take, like, say, 3 points and use that data to find the quadratic function. So the first thing you want to do for identifying quadratic data, that's the first thing we're going to look at. And we need to look here, this is a very important note, you need to decide if the data is quadratic. To do that, you have to look at the second differences. And you'll see what we mean by that in a second. So let's look at an example. Here I'm going to put a table. Notice that all the x's are equally spaced apart. So you look at the y's, and I'm going to say here, what's 12 minus 10? That's 2. 10 minus 9 is 1. 9 minus 9 is 0. And 9 minus 10 is negative 1. Okay. Those are the first differences. So keep that in mind. Those are the first differences. Since they're all different, I can now look at the second differences. When I look at the second differences, 2 minus 1 is 1. 1 minus 0 is 1. 0 minus a negative 1 is 1. All the second differences are the same. Since the second differences are the same, this is quadratic. This function, or this data, is quadratic, or would represent a quadratic function. So let's look at another example. And again, you can see here, here's the data that we have. We're going to look at the first differences and then the second difference. It's important. If you have to first have the first differences be different. Then you can look at the second differences. So I subtract 1 minus 2 is negative 1. 2 minus 4 is negative 2. 4 minus 8 is negative 4. 8 minus 16 is negative 8. So I can see here that those are all different. So then I will look at the second differences. When I do that, I get 1, 2, and 4. Since the second differences are not the same, this is not a quadratic. So not quadratic. Okay, and that's it. So let's look at one more example. And again, notice all these, the x's are spaced evenly. Okay, so I'm going to look at this, and I'm subtracting. I should have put negative 2 on all those, but all those are basically 6 minus 8, 8 minus 10, 10 minus 12, 12 minus 14. Notice they're all the same. Since those are the same, the first differences are the same, you don't even need to look at the second differences, and you're just going to say, this is not quadratic. It's actually linear. Keep in mind, you can only look at second differences if the first ones are different. So that gets us to the second part of this lesson, which is writing a quadratic equation or function from a specific set of data. All you need is 3 points. So the big thing is that I will have to give you 3 points, and then you can find the quadratic equation. And I'm going to tell you how to do this from the calculator. I will probably try to add some pictures in here so maybe you can see what it would look like. But keep in mind, pay attention to what I'm telling you to press, because that's what's going to be important. So what we're going to do is we're going to try to get this in the form of ax squared plus bx plus c. Notice here I'm putting a 1c because that's going to become important later. So here's 3 points, 0, 5, 2, 1, 3, 2, and think that those points, if you put them in to the standard quadratic function, the standard form, ax squared plus bx plus c equals y, then you're in a sense saying 0 squared times whatever a was, plus 0 times b plus 1c would give me 5. Okay, and I'm writing this out, you can kind of see. Okay. So you can see here, I'm rewriting this where I actually squared these numbers, and I'm showing you the reason why I'm doing this. But what this is doing is enabling me to have what is a matrix. Okay, notice all those numbers that you're seeing, the zeros and the 4, the 2, those all represents the numbers that are, say, the x's. Okay, and this is going to help us find the A, B, and C to make the equation. So I put this in, and I can use matrices. So if I use matrices on this, I should be able to answer this. The matrix would look something like this, and hopefully you remember how to do a matrix. If you multiply, we do inverse matrices, okay, and this is the reason why I would like inverse matrices. You're going to type in, remember, we hit control times to bring up the matrices. You're going to type in a matrix that has like an x squared column, an x column, and then a column of ones. Raise that to the negative 1 power times the y's. And then that will give you an answer, negative 1, or 1, negative 4, and 5. Those are your A, B, and C, the numbers that go in front of the x squared, the x, and the number that's all by itself. Okay? So if you have any questions on that, we will be practicing that tomorrow. I can go over that, but that's what you want to look at. So to look at it again, keep in mind, this is something for your note card. This is what we will always do. You will always have a column of the x squares. Whatever the x numbers are of the points, you will square them. That will become one column. You will write them normal. That will become the middle column. And then you will have a column of nothing but ones. Your y's are always separate in a separate matrix, like your answers. Okay, so you can see here 0, negative 3, 1, 0, 2, 1. And notice how I'm writing this. 0 squared is 0. 0 is 0. Okay, and then there's a 1. The next column, there's the y. 1 squared is 1. 1 is 1. 2 squared is 4. 2 is 2. Okay. So this column, this first column, is 0, 1, 4. Those are all the x's that were squared. The second column is just 0, 1, and 2. That's just the x's. And then the third column will always be 1. And then the next matrix is just your y's. Type that into the calculator, press enter. You end up with negative 1, 4, and negative 3. That's your A, B, and C that you put in front of the x squared, the x, and then all by itself. Okay. That's pretty much it in a nutshell. That's all you really need to do. If you do need help remembering the steps on how to type in a matrix into a calculator, let me know. Be sure to ask tomorrow, but that's it for 5A.